Yeah. You see it?
Okay. What am I? So
Okay. It's a point cloud, right? Like so you see how these are like points in space, right? Like they're like little dots in space.
yeah.
Okay, so basically, an LLM, right, is all the information, all the parameters. Parameters are basically the rules that the AI sets for like language, information, or whatever. So when you throw information like through, like, okay, let's make this a little bit more visual. So think of information as like a white bright light, right? So, and then you have these things called parameters, which is kind of like a prism, right? It's kind of like the Pink Floyd album.
Yeah.
I don't know if you listen to Pink
Yeah.
Floyd,
No.
but
Yeah. No. I know what you're talking about.
so basically, here, I'm just gonna pull this up just to like make this a little bit simple,
It's
right?
almost as if a metaphor for. Hold on. Let me. The it's this reminds me of very specifically a It's funny. It's really funny. You'll find it. Um.
Let me know. Let me know.
No, I'm with you. I'm with you. You can keep going. I'm just trying to find something to show you,
Okay,
because the chart,
over there.
um,
Mm-hmm.
but like the moment of the Big Bang. So what do you call that moment of Big Bang?
No.
No,
I
no,
wouldn't say this is
no. This is
this is
this is
nothing like the
this is
Big
I
Bang.
no. I understand that, but it's just the pictures related. So it's just like through this, if you just and it's such a loose metaphor, so you really have to pardon me for going off on such a branch here.
Mm-hmm.
um where the hell is, I've got the picture here. I'll send it to you in a minute.
All right.
So this is all little bits of data inside of a set of parameters, which is then passed through to the model.
No.
How many
It's
steps
Not
then?
little set. Okay. Let's remove steps and let's just break it down to kind of like its most core components. Okay, like I don't want to go into the math or any of the weird vocabulary that comes along with it. I just want to basically explain it to you in a way where it's like super fucking easy to understand, right?
Mm-hmm.
So like let's use your brain for example, right? When you like remember a memory or you make relationships in your head, you're basically saving things to kind of like a 3D kind of like vector space, right? So things that are similar to each other would end up in kind of like the same part of your brain, right? Like if you're thinking about dogs, there's going to be like a 3D point in space where you kind of like
The
put
neurons
that
are
information.
activated on a certain set of neurons in the network
Yes,
when you've got a dog.
yes. So basically, right? Like what happens is you're basically going to embed information through a set of rules that turns it into kind of like this 3D vector point. So that's how you embed information. When you embed information, it's basically if you're going to talk anything about dogs, right? You're going to go ahead and then immediately kind of like, let's just say we put it in the top right XY plane. But when you're talking about cats, it's going to be in the like the completely opposite
Different
side,
XY.
right?
Different XY.
So what information it is, right? Let's just say like you're like right now it's currently mostly text because of the fact that you can't really embed images without kind of turning them into text, right? To turn it into
Yeah.
information like vector points. So kind of like how I like to think about it is like this. Let me just open up Excalibur, right? Um, Give me one sec. Let's open up and like like the same way that you put information, like let's just say that you were to embed information with other terms, right? You draw this out. Okay, that's the okay.
X, Y, and Z.
Yeah, X, Y, and Z. So, and so let me just grab this tool, and then we're just going to put a bunch of points in here, right? And these points are like information, right? So each one of these points, let's just say like they have like a certain value,
Yeah.
right? Um, and what you're basically doing is the same way these informations ended up in this like 3D space.
Mm-hmm.
When you ask a question or you ask a, hey, I want to go ahead and then find this, right? Let's just say white is equal to, let's just say white is equal to dogs. Okay, and then the blue point, let's just make it, oh, it's not blue. Just make it be cats. And then the last one, let's just make it be fucking, I don't know, perfect. Okay. Super fucking perfect. So the same way that this information ended up in here, right? Like you have like a rule, like you have rules. So if you shine a certain like type of light into this prism, it's always going to reflect the same color. But then it also works backwards, right? So let's just say that like, oh, I want to get like, some information about dogs, right? You're basically creating like a 3D.
Can we change the model a little bit? Can the birds just be a subset of every other animal essentially? Is that okay?
Yeah.
Okay, I just wanted to make sure.
Really
I just wanted to be. I wanted just to be maybe.
Okay, so basically when you go ahead and put your information through a process, right, you're basically putting it into like 3D space. And then when you're doing retrieval augmented generation, right, your prompt gets turned into a point in 3D space, right? So let's just say this is our prompt. It asks something about dogs, like this circle with white. What is it gonna do? Your prompt, it's like, let's just say, get me information
on birds
about beagles, right? And bullshit like that.
Mm-hmm.
So information about beagles is also is a point in 3D space that's going to be around here. And then what RAG does, it does is like a vector similarity search. It finds which are the most nearest vectors, right? So using this kind of like 3D point in space, it kind of does the opposite. Instead of putting information to the 3D space, it uses this kind of like 3D point position from the question to find out what's the information that's the most close to it. And then that's how similarity in things work. So if you were to ask anything about cats, right, let's just say, let's create a blue circle now, right, blue. And then let's put
can I just tell you the stupidest thing in my head right now while you're typing that?
Mm-hmm.
It's like ever since we moved spawn, like I found 0, 0 coordinates. And then we found the Gmod build gun as well. That sounds so fucking retarded, but
I don't think you're understanding it. I played a shit ton of Gmod. I'm just letting you know.
Well, I mean, it's just like when you first open the menu, like that very first time when you open the menu.
So I'm just saying, like...
I mean, I understand tokenization of how the prompt gets passed and how it gets broken down from, like, down the individual letters. This has nothing to do with prompt.
But like, outside of the letters, right? Like, you're talking about tokens. Right? Yeah. Tokens basically don't carry meaning, right? So basically what you're doing is after your text gets tokenized and all that bullshit, it gets turned into a meaning, right? Like a singular like thing that encompasses everything between it. Like all the tokens, everything that's inside of it, it gets turned into a meaning, which is a value. Mm-hmm. And so depending on that value also gets put into 3D space. But instead of putting that information into that 3D space, you're basically going to see what's the nearest information to it, right? Instead of placing the information, you're using that point in space to see what are the things that are the closest to it in terms of meaning. So if you have a bunch of shit that's like about cats and you ask something about cats, the point in 3D space is going to be near that point cloud, right? So this is kind of how it looks like. But let's just say, so here, look at this part. This is where it gets pretty fucking cool. So let's just do like a little bounding box, right? So, okay, we're gonna go ahead and do this. Let me know if you can see it.
The letters?
Okay, you see, no, it's not letters. It's literally points in 3D space. You see how
a single vector through the chart.
Yeah, it's not about a single vector, but it's about what's the nearest thing to that vector. So let's go ahead and press on this oak vector, or Mississippi. Let's do Mississippi since it's right here. So we're going to press Mississippi, and then we're going to see everything that's related to it. You see how all these things lit up, and all the other points like went away? This is a point cloud of meaning. So this is how RAG works. Like if you were to ask anything about Mississippi, you would go ahead and then look at all these other bits of information that are near it. And then over here on the right, you're going to see that the nearest thing in semantic information on the right is Missouri, Louisiana, Ohio. It's going to list all the states because Mississippi is a U.S. state. And that's information that's embedded within Mississippi. So it's only going to do things that are related, like Mississippi, like Confederacy, the North, the South, anarchism, places, right? Mississippi is a place. So you'd expect information that's on this RAG embedding cloud to be, like related to a place or a time or its history. So that's kind of how it works. And so you see how basically this right side of information is all written down. It all has to do with places, while I assume that this other side over here, it has to do more with meanings. So for example, input. So input is a definition, but the point cloud is only in this part over here. All the things that are related to it have to do with similarity, right? What's the nearest point to this information that's called input? So when you're working with RAG, right? I don't know how you'd use RAG in Cookie Clicker. Okay, I'm just letting you know. Like, there's no
essentially, it's just maintaining API arguments. It's just helping build out the backend. Just so
okay, then
that makes more
just
sense.
Use agent. Yeah, no, it makes 100% of sense. Like, what I'd recommend you do is like, dude, just literally use Agent-MCP, but don't use agents. Just make sure that you tell like the admin agent or whatever, just give him his token, and then tell it to remember everything. Because like there's already a pretty well-defined RAG part, and I'm gonna tell you, you're throwing yourself down a 2 to 4 week project on just figuring out RAG for semantic knowledge. Like it is, you need to read papers, you need to understand the math. It is very intense. Okay, like I'm just letting you know. Like this is what I do. Right now I'm currently redesigning the whole RAG process to make it a little bit more reliable for agentic collaboration. But as of right now, when I'm working on something with like, for example, here I'll show you how I work. Right now I'm kind of working with a new project up here. Let's go to let's do Swarm. Okay, we do have .agent, and let's test this shit out. Let me go ahead and start up Agent-MCP just so you can see this. And you don't have to use it. Like this is one of my like projects that I don't use multi-agent collaboration because it's a very complex project. So I only use it for semantic knowledge. I only use one agent, and I make all my changes linearly. But here's let's see the Agent-MCP. You the run maximum agent complete for the 80 dash project there. We're gonna make this a whole lot easier very soon, but this slash EPS Clover, and so we got the admin token, and we're gonna get the quality. Let's make this a little bit bigger. You are the admin agent. Please tell me what you know about the backend and the API. This is your admin. So, wait, let's do some CPUs. Okay, wait, I need to add it. CPU fits the problem. That's I'm just showing you because it's like I'm gonna tell you the truth. I don't want you to get into a disgusting kind of like battle that I've been getting into myself for months. Okay, so here. At this point, this system works very fucking well. I use all the latest research, right? So here it's gonna ask the project RAG. So let it ask it. It's gonna return the embeddings. So here, give me 1 sec. All right, so here, let's just stop this. And this is the semantic search that it does. This is the tasks, but this is how it returns the information. Agent-MCP, the project RAG, is really good right now. People try to use it for the fucking agentic part, but I really think the knowledge and the RAG part is probably is the strongest aspect of it. So here, based on all the information that I've put into it, or that the agents have put into it, it tells you, okay, the backend API.
So have you seen the MCP registry? Are you on there in the 340 or 396? Do you know about that yet? Did I send that to you already or no?
MCP register.
Yeah, it's one of the repos.
This one.
So it's like there's some standardization of the entire thing. I don't know.
Where?
I might have not sent it to you yet. I thought about sending it to you earlier, but I just never made it.
Oh, it's all good. But I'm just letting you know, like, for example,
It's just to help. It would help further your mission, I think.
well, most of the mission at this point it has nothing to do with RAG. It has more to do with the information that you segment with RAG. So here, let's see, introducing MCP for agentic RAG. No. I've used most MCPs that have to do with memory, but they use like not a very dynamic form of memory, and I don't think that it works. Like Context 7 is very good at documentation.
Because it all pulls from GitHub, and it makes a single call to pull all the documentation. So
no, it does a lot more than that. Like I recreated Context 7 these like last few days. It's a lot more than just pulling information from the GitHub. They ingest the data, they run it through AI, for retrieval. That's how Context 7 works. Like they don't literally just slap you the fucking documentation. They go through the documentation and they run it through AI to make it more digestible whenever your agent has to ask a question.
But how much is really being lost at that point?
What do you mean lost? It's very good. Like I've made my own implementation and I ran into it. It's like these are just things that like if you're not building like kind of like for example just look at this retrieval, okay? Backend APIs and services from the context key PDF quote backend. The Go backend exposes several REST API endpoints. Quote management, post API view one quotes, creates a new post, get, retrieve a quote, right? PDF generation, generate and download a PDF for a specific quote, right? Where is it located? The service handles all the PDF generation, and then from an architecture, it breaks everything down. So
what program is it pulling from then? This is just your current context? This is your current program?
Yeah,
this is Clover? So this is so this is the app you've been working on. So
yeah. Continue.
So and this is your loaded up RAG giving you, and it's written in Go, and this is so what you fed the RAG exactly? What embeddings did you feed?
I feed Agent-MCP automatically logs every single markdown that's inside of the code base, and then outside of that, the established workflow, right? So here I'll show you by doing /memory. So /memory, this is the memory that we use, well, that I created basically, where it tells it instead of giving it project information in the cloud.md, I give it behavior. I tell it how it should interact and how to work in general. So I do plan, act, and auto. This is something I've been doing for months. And then fucking stock trading Discord. These guys never stop fucking talking. Okay. But basically, I always tell it that after you work on an implementation, I want you to reference the code location, what lines you changed, and how it works. Because, like, most people that do RAG, for example, cursor shits the bed when it comes to embedding. I hate the way that they do it, and I think it doesn't return, like, a good way, right? So, we don't want to basically, like, embed code. We don't want code embedded inside of our content. We want to embed meaning and understanding and give it the location to go ahead and read on its own, right? We basically want to like be like a good teacher where we tell the student like, hey, this is what you need to understand. But if you want to understand it better, you need to go to this book and this chapter and then read it, right? Like that's my methodology with how I work with RAG. I don't want to embed code. I don't want to embed like definition.
It's like calculus almost. It's like you're doing calculus as opposed to x and y and a different x y, and both of them are moving at the same time because it's calculus. But
well, forget everything that has to do with 3D space, right? Like like I don't do anything that has to do with math. For example, I use math that has worked out in the past, and I don't rethink. Like there's no reason to go down into that rabbit hole of crazy fucking math.
well, yeah, no, I agree with you there. I'm not interested in that. I'm not interested. That goes down all the way to the tiny, and I'm not interested. I'm not interested. I'll go the other way. Thank you very much. I can build shit. I can't do math. Fuck that. So very specifically the embeddings, and then however you get the embeddings to selected, and however your specific highlighter works for your embeddings in order to throw them into the RAG. But how does the RAG get called? The RAG gets called all at once, and that injects the entire RAG.
No. It's okay. Let's go back to the Excalibur drop. Okay. So here, right?
Okay.
We're gonna use this kind of like.
So when I said the vectors, it's like lining up one of your vectors better.
Okay, so let's do this, right? So this is an empty RAG repository, and then no data. Well, let's do this as if it was a fucking separate. So we can slide. Let's grab this. So you have this, which is an empty
RAG.
Empty embeddings. RAG is not embedding. Okay. RAG is how you pull information from embedding. And let's just say you have this information. For this example, right, we are going to embed, I don't know, let's do Coca-Cola, right, embed Coca-Cola. So we have data, okay, let's just say that the data is, I don't know.
The 2 million lines of code.
2 million. Oh, okay. So okay, all right. So now, is that? Oh man, dude, I can help you. I can help you right now. I can help you right now. This is literally what I made Agent-MCP for. So cookie clicker repository. This is literally why I fucking Agent-MCP. Do this. So we're gonna get the files. Ding, and we all the code.
Yeah.
So you want to transfer code to embeddings, right?
Yeah.
So slide.
And then I wanted to be able to pull it all at once, and then I've got opposing vectors, and I need them to be able to intersect.
Listen.
I'm digging a tunnel.
Listen. Use a. No. You're not digging a tunnel.
It's like a tunnel, underground.
No,
You don't
no,
think?
you're not.
You don't think that's not what it is?
Not at all. Okay. So listen. How to embed data. Okay. So the first thing that you need to do, right, is break this up to chunks. Right. That's the first thing you need to jump into the main thing. Okay. Let's go to the next one. After that, you grab those same fucking chunks. Oops. Chunk one. And then we're going to put this through our embeddings processor. Okay?
Mm-hmm.
Embedding. And so how does the embedding agent work? How does the embedding engine work? Right? That is something that you might be asking. Okay, so the embedding engine basically oops. Okay, let's some data. Data goes into the embedding engine, and then the embedding engine basically goes ahead and then puts it as like a 3D point.
Okay.
So let's just say let's put this as blue. Okay, and let's just say create the arrow goes from it to this. Embedding engine turns the data into space where the dot orange represents but these are things that you don't even really need to kind of like learn, right? What I mean by that is
I think it's really important actually.
I don't think so. I think that's basically just they're just basically relying off of the research and the math that these like scientists have been like working in. You don't need to go into kind of like the logic of embedding. I mean, like now it's like it's like it's like how I asked you about like like you don't go to the people who made the fridge to tell you how to fuck you make Coca-Cola, right? Because Coca-Cola only got rich like because of the bridge. The bridge didn't know how to use their own technologies, but that is a separate thing. So after you embed everything into space, right, to these kind of like points in space, you kind of end up with the same point cloud that we showed up, but
like when the first, like one of our first sessions when you had the star with the dots flying around it, when it first started going, when it first starts going.
Well, those are just tasks. That has to do more with Git than it has to do with kind of like
the concept.
Like,
but
like
that is that a fair example?
No.
No. Okay.
No, because you're talking about the dashboard, right? That I showed you of Agent-MCP. I don't even use that dashboard personally.
Well, I'm using that dashboard and its population metric, and the way it populates in the same way as the fourth slide on the right. Do you know what I mean? So you go from the empty to then you go through the process. You go through slide 1, 2, 3, 4, and then you end up with a whole bunch of points like this, and this is your RAG. This is the RAG that you've embedded, and it's all contained inside of the RAG, of which.
Well, this is not RAG yet.
Okay? Not yet.
This is not yet. Okay, so like, what basically happens? Put this way. So maybe I want to right? After this, what is RAG? So you have prompt, you have a model, and then you have embed. So basically, this is how it goes. We're gonna do this. User prompt the model for information. And let's make it small. Sends it over to the fucking RAG. Let's make this big again. Model turns from into meaning into a 3D vector point. And new embedding with determines the embedded points that are most near the information box. So basically, it turns the prompt into like what we said, like a point in 3D space.
So this chart can be compared to the fourth one in the same way of that the prompt is the data, the model is the embedding agent, and then it's going to.
The model doesn't always have to be the embedding. What I mean is, you have, let's just say you have a graph, right? Like what we said, we already have this graph, the embeddings data. Mm-hmm. Okay.
Well, that's what it's so, that's what, assumingly, as it's pulling data, as the model is going opposite as opposed to the process. Like we're on the other side. Like it's strange because I feel like I'm going the opposite direction as you. But it's then it turns it so then it goes with the prompt with its own embedding, and then hits the chart, and then bounces off, sends something back, and then that's the response.
And smaller. So now let's do another arrow. And then now we'll use original prompt plus embedding information to the answer. Proceed. This is how it works. Super simple. And here, let me just go ahead and then visualize it. This is literally how RAG works. This is the most simple way. You prompt the model. The model turns that prompt into a 3D point in space. That 3D point in space returns the vectors that are the closest to it with the information that's inside of those vectors. And then the AI uses the original prompt and the information from those points that, not to decode it, to enrich it, right? So like, let's just go into it, like news. So
well, I get what you're saying. I know my phrasing is different than what you're saying, but please continue on what you were saying because I feel like I'll gain more from what you're telling me. I could. I mean,
so
I think you got something.
So still. Okay, so user, right? We're gonna break this down into prompts. let's just say that this is, okay, we're gonna do example, rag, rag system for type messages.
Perfect.
Okay, super fucking simple. User. Then we're gonna say, directed Lindsay asked me to be likely. Okay. What did Lindsay ask me to do last week? Model.
Yep.
The model doesn't know anything, right? Let's just say model
It's a
is
calculator.
GPT.
It's basic input output.
I wouldn't say that it's a calculator. But let's just say that it just doesn't know GPT 4.1.
Gotcha.
Okay.
I understand.
For this example.
I get what you mean.
Model does not know anything about the conversation. We're just gonna put that just to like
It's extra
kind
dumb.
of, you know, yeah, like just to explain it a little.
I hear you.
Model conversation, and then let's do this. Model turns it into a point. Nice. So it turns this prompt.
It flips it upside down, let's say. Can you twist it? Just twist it all the way upside down on the other side of it.
No, here. I'll do even better.
There you go. Real pretty like. XYZ. Perfect.
That then gets fucking thrown into the embedding. Just do it like this. Embeddings. And let's go grab this embeddings data. Oh. Bitch. Put this over here, a little bit below, just so I can make this chart a little bit
There you go.
composite.
Wonderful, wonderful.
So let's make this a little bit bigger, just so I can play with it. Create a white circle right here. Let's do like a little key. So, and I'll send you this presentation just so you can like basically like look at it.
I appreciate it. Yeah, I'm recording this. Do you mind?
No, I don't mind. I record everything as well. It's all good.
This has been very enlightening.
Mm.
I gain a lot. I gain a lot with time with you, my friend.
All good. Whenever. I thoroughly enjoy doing this shit. So yeah. Oh, no, there we go. So here, let's just to closer, and let's get a little skinnier line. Basically, starts doing things like this. It just starts returning the points.
Yeah.
Okay.
So the
and then returns Sports with the information. And it's organized still with that.
Yeah, you're
We're gonna
good. You're
get
good.
there.
I appreciate you. How many times do you use this application? This is cool.
I use it for everything. Been using this for a couple months for all of my ideas.
Very cool.
This is what I use for everything basically. When I present presentations and stuff to people at the company, I also use this. So what does this look like? What the fuck does this fucking piece of shit embeddings information look?
So can I add a vector?
Yeah, sure, I guess.
So the model, whatever it's handing off to, what the XYZ coordinates also contain the instructions for like receiving the information and returning it back. Does that make sense? That's what we're saying the same thing, aren't we?
Repeat again.
So the embeddings give you an XYZ. You go through the embeddings engine, it gives you an XYZ, right? Just one to represent the entire set of embeddings because we're dealing with a bunch of birds here. And like imagine tracking birds through the air, a flock of birds through the air and modeling that. So the only way I can throw this rock and take out as many as possible is to say I need the rock to go through at this angle, and so these are the birds that are going to be hit, so it needs to return a certain set, like it's gonna be like, here are the birds through the through that vector. This is where you're gonna have to find the stone.
Sorry. Repeat again. That was I was very confused listening to that. Like, so basically, you're trying to throw a rock at some birds, and you're asking the AI which bird to throw the rock at,
and where to find the stone after, and where it would land, and every possible nuance of other metadata that we can extract in the entire.
I think like if you could like simplify like the example you're trying to use it to,
so prompt A, it gets the embedding points. It then has just put it like this. Put like a purple circle, and that's going to be the return prompt, right?
No, there's no return prompt.
It needs to send something to the model in order for the model to turn it into plain English, doesn't it?
No, like the points. Like let's just say this point right here, this green point right here, this one that I'm like circling. This point is this piece of information over here. This point is basically, it's going to return this. This is what it's going to return. It's going to return. This is the vector point 0.23, 0.44, 0.85, and like Lindsay says, hey, do you want to go a bunch next week?
On that date and time.
Well, like yeah, let's just say
with the the metadata. Let's just say with the metadata, because that would encompass everything I said as well as everything you said.
It wouldn't be just the metadata.
It would be. I mean, it would be everything, but.
Yeah, because it's one point. You can't have one point that's going to return basically a bunch of other information. Like the metadata is the point. Basically, this is the point. The point is going to say this point is this information, nothing else, right? There's obviously going to be a lot more relationship, but like the best way, like this is the most simple example I can think of. It's like, okay, hey ChatGPT, what the fuck did I do last week on Thursday? And then it's gonna go, okay, it's gonna turn that shit into a 3-point. It does it automatically. It's not like it needs to do a prompt and then it searches for the embeddings. Like automatically, like the prompt gets turned into a vector, and then After that, after the embeddings engine kind of returns the additional information, that's when the actual thinking process or the prompt that you're kind of used to happens, right? So first, it turns your prompt into a 3D vector. Then it goes into this embedding struct, pulls the information, but this is like hard coded shit. This is not something that the AI is agentic
No,
or
I
anything like
understand that.
that.
I
Right?
understand that.
Like,
It's
and
I'm
then
several
after
levels
that,
higher than the abstraction.
it kind of it like so it does like this. So the actual prompt, this is what it would look like.
So here,
So
can you just make that? Can you make this? Can you just blow it all the way up again so I can take a good screenshot?
I'll just send you the
No. Well, no, but I just want to because if I draw on it, maybe you'll understand what I mean differently.
I can share the notepad with you.
Oh, can you?
Yeah, you can do a bunch of shit with this.
Is Discord? Oh, Discord's over here. Is the? I thought I popped it out. Where? Hold on. This is all screwy. Hold on. Oh, that's why. That's why. That's why. Let me get back to it. Let me get back to it. Give me a moment, please. Okay, I got that. I got this back up. And then we go back to full screen. Okay. Whoa. And we're all the way over here. You're just building further stuff out. Okay. So
Yeah. I might use this presentation to explain it
I
to
would
other
love.
people.
I can upload this immediately. So so over here, right? This is basic input output, right? I mean,
Well,
we've got
there's no input output. Yeah, like yeah, there's like input output from
we,
model
we,
and the
we,
embeddings, but
we've got the embedding stuff over here, and then we're gonna say that we've got oh shit. Then on this side is the magical decoder, right? And then somewhere inside of this set, right, is some other set for the same thing. Just where's the arrow? Just it's got specific set of instructions to grab based upon as well as this information which we put it in over here.
No. You see how these points are super far apart? There would be no relationship between those 2 points. Things that are related together in meaning. There's no instructions in embeddings. It's all just meaning.
So specifically, we just have to, on some point, throw different context at it, right?
No, the points have the context. There's nothing smart about this. It's all you're like. It's like you turn knowledge into a vector, and then the things that are nearest to that vector are things that are related to it. And so when you ask a question, your question gets turned into a vector, and then it gets returned information that's near that vector. There's no instructions that tell it, oh, this vector it also depends on this vector. Like no, it doesn't work that way. Like there's no instructions inside of RAG. The RAG is only this is my nearest neighbor, which is that's how it's meant to work.
So the prompt hits the embeddings data, right?
No, it doesn't hit the embeddings data.
Just bear with me. It on the basic
No,
when
yeah.
it referenced the basic input output system. It hits the embeddings. It then processes through that vector, We fly through the bird cloud, and here are the birds that we've hit. And then after it's gathered all of the data along this path and tracked out shit. Do I just press Control Z?
Mm. Yeah.
Once it's
No, you're overcomplicating it.
just please please.
This is super overcom. I'm just telling you, it wouldn't work that way. That orange point would not get near that the white point. It wouldn't even be. It would never be retrieved. There, you don't use embeddings to find the information that's between 2 points.
The process of this white thing, of this white with the arrows, is the same thing as this orange thing with these green arrows. These green arrows and these white arrows are doing the same exact function.
No, they're not.
You don't think so? You don't think that's possible?
No, they're not. It's not how it works. I'm just saying, you're getting very confused. It's literally just as simple as like a simple x. Let's make this even more simple. Okay, so let's just say you have 2 points. Okay, like you have only 2 dimensions, x, and you have y. Oh wait, x, and then you have y. Okay, and so let's just make this super fucking simple. Okay, let's just say we have 1, 2, 3, 4, 5, 6, 7, 8. Let's do them different colors just so we can go ahead and like give like a key to what information means. Okay, let's get color, purple, and let's see, different color blue. Okay, so these are all embeddings, and all of these points.
Do you just have? How do you start typing? Do you just start typing?
No, you press T.
Oh, T. Okay, and then okay.
Yeah, but I'm just saying. I know.
Continue. Sorry, that was totally. That was because I'm just trying to formulate what I think you're saying.
Okay, so look. All right, so let's just say that this point is equal. Let's say that this point that's in the middle is equal to 0.5 and 0.5.
Well, so is that a specific point, or is that the point?
Yes. This point is a very specific point. It's this
okay.
Point here. Okay.
Inside of the subset.
Yeah. Inside of the graph. Let's just use simple 3rd grade language to like kind of like narrow this down into something that's like easily understandable. Okay. So 0.5, right? Let's do the same thing for the other point. Okay, it's equal to 0.4 to 0.5, right? And let's also go ahead and just grab the red one. Say that the red 0.2, 0.2, 0.8. And let's do the final one. Let's just do green, forget the last blue one, which is equal to 0.5. That's super fucking simple. So the green color with the dot. Outside of those vectors, right? They're also they also have meaning. So like the point also, let's just say green represents, let's just say, is equal to okay, let me just do this just to like make them vectors. Data over here. And so these points also have information. Say that this point, super simple, is Ferrari. Let's just do cars, okay? Just to keep it like Ferrari. Here. Here.
Just change the text.
No, yeah, that's what I'm doing. I'm just kind of getting rid of the.
You're being all fancy with it. I got you.
No, yeah, it's worth it because if anything, I'll just like I use
Production
I
quality.
reuse
You're right. Yeah,
station.
you're right. I know you're right.
So here,
I know you're
let's
right.
do
I am just impatient. It is, pardon me.
all good, all good. So here, dodge. Let's do is equals to Camry, okay, and
Can it be a
do
Kia
this
Rio?
one is equal to Toyota.
Toyota. Or can we not make it Toyota? Or is it? Oh no, continue. I'm getting lost. I'm just getting lost standing here. That's it. Just keep going. I'm following.
Okay. So like you understand that this vector, the blue one, right, is also a fucking dodge, right? Like this point over here, 0.5, 0.5, is over here in the middle, which is dodge. Right?
So,
like this,
semantically, you're telling me that the colors of the dots have the same meaning semantically.
no, they don't have the same meaning.
You're not telling me that vectors equals data.
No, like the data as a vector. The information of what Ferrari is a vector which is 0.15, 0.15.
It's just different phrasing of the same thing, isn't it?
No.
So you're telling me that just because the category is Toyota, it's got all of the subset inside of it with the X and Y?
Yes. So Toyota has its own X and Y coordinate.
Yeah, so I mean, Toyota, for lack of better words, is equal to X and Y. Not
Toyota is
I mean,
well, like how are you using X and Y?
Okay. Toyota. I would understand this chart as Toyota equals 0.2 equal 0.2 comma 0.8. Toyota.
Yes, exactly. So Toyota, like the meaning of what Toyota is, it's inside of vector space 0.2, 0.8. Okay. So this is your embeddings table. Okay.
And this is equivalent to the chart above, the same exact thing.
Yeah, this is the same thing, but in 2D space, right? It's just like in 3D space, you kind of have
a different set of
like. No, it's the same thing. It literally works exactly the same thing in 3D space, but this is the embeddings table that we have above. Okay, so we're gonna copy this embeddings table. We're gonna put it over here. Okay, but this time we have a prompt. Let's do I don't know, like, fastest car in the market.
Yeah.
Okay, this is your prompt.
Mm-hmm.
That prompt is equal to let's just say, Ferrari was green, so it was 0.15, 0.15. So let's just say that the prompt is equal to point in space 0.20, and then
can we just make it Toyota? Actually, can we make it just for set reference? It could be 0.2, 0.8, and that is or put it close to 0.2, 0.8.
But like why Toyota? Like it makes no difference which one it is.
I mean, okay, so fastest car. I was just going with the color, but fastest car, green, sure.
Yeah.
Okay.
So the fastest car, right? This gets turned into 0.2, 0.25.
Because it's right next. Prompt, it's right next to the green one. Gotcha.
Well, not because it's right next to the green one. The green one got put there because of the LLM's meaning behind it. There's no way for you to dictate where in space.
So the concept of space here is very liminal.
Yes. So here we're gonna go ahead and say that this is the prompt, right? No background. This empty one right over here, 0.2, 0.25. Mm-hmm. And what's it gonna do? It's not going to return the fucking purple one. It's not going to return the orange.
It's the closest.
It's only going to return
something that is a shade of green.
No. There's no color green.
But a shade of
There's no
Ferrari.
colors.
Okay, a shade of
There's no
Ferrari. Does
color.
that make it better? Does that make it worse?
No, there's no colors. There's no colors. Like all of these points in reality would just be a point. There's no differentiating factor between there's nothing where it makes like one point more important than the other. All points are equal. Every single point is equal.
Yes.
Every single one. The only thing is you're just looking for which point is the nearest. So here, fastest car in the market, the model would return. Model returns Ferrari. It's the fastest in the market. Like, let's take this example to, let's go ahead and copy this. Let's create a new slide. Okay.
There. You got it. I got it.
So here, fastest car on the market, and let's copy and paste this again down here, and we're gonna do prompt equals reliable and cheap car that won't break on me.
And then
So
do we just put this giant chart on a small X and Y? Like this entire chart would just be a signal.
We're just reducing it down to XY. In reality, the embeddings models, they use 1,536 or even higher dimensions. We as humans can't even begin to understand or visualize the actual dimension.
536 was a specific number?
No, 1,536, 1,038, 3012. There's thousands of embedding spaces. The more dimensions you have, the more specific you can segment information. So in this case, we ask the AI, right, with the RAG, what's the most reliable and cheapest car in the market that won't break on me?
Where I don't see... Ooh, this would actually be... Okay. Hold on. Keep going. Because I couldn't see I couldn't see your mouse as you were waving at it.
Okay, so this one, it would be 0.2. Oh, let's just do 0.25, and then we do
you don't have to think about what it looks like at this point. I can just
no,
make it. I can center it.
It matters.
Oh, on your end.
It matters. Okay, so in this case, right, this point in space would actually be over here. And then it would return this. So model returns Toyota is the most reliable car in the price in the market. Let's use this effects. That's how this is literally the simplest way to understand how RAG works.
So the thing I'm wondering, right? So this abstraction as well as this abstraction over here with the XYZ are exactly the same. Yes?
Yes, it's just like your prompt gets turned into a point in 3D space, and it returns the points that are nearest, and then when it finds like the points that are the nearest to it, it also gives a text that's associated to those points. So this point in space, right, is first it's going to be like, okay, we're going to embed 0.25, 0.95. What's the nearest point? 0.2, 0.8. What is the information inside of that point? Toyota, right? So then the prompt gets your prompt with the embeddings returned.
So, bear with me for a second, and this is just going to sound really, really silly. Like, what's the easiest way for me to... So, I'm just worried... You know how we were up here with the basic input-output? If you come up here to the embeddings? Like,
yeah.
This was basic input out here. This is still basic input-output. So, this fastest cars on the market, we end up back here on this user prompt. It hits the model, the embedding. We've got these points in space, and
And it
then
returns the nearest points in space.
so what if these nearest points in space we just have some one thing weighted really heavy on the table, extremely heavy, so that no matter what, it's gonna. So it was 0.23, 0.44, point or negative 0.85, right, or
There's no
whatever.
weights. There's no weights in
Just
embeddings.
bear with me for a second. We make it close. We make it one of the close vectors.
You can't control where it gets embedded.
So just back here on the prompt, it's I'll get back. So I run the prompt once. I get back this set of data. Where do I?
No, you don't return. This doesn't get back to you. This gets back to the model.
This
And then
gets
the
okay.
model
Okay, return does it again.
So the model basically. Let me just delete this bottom part, right? Because I already have it inside of the other screen. Boom, boom, delete that. Okay. So the model uses the embedded point. The model uses prompt plus embedded plus data return from RAG to answer the question. So it looks something like this is what the model receives. And do this.
The response prompt, you mean?
There's no response prompt. This is the user
Or
prompt.
or the initial. So we're up here right now. We are like on this initial user prompt. That's where this is equivalent.
So here, look. So this is the next part. Retrieval.
Okay, you got me. I understand where we are. So model return. The Toyota is the most reliable car on the market. Is the RAG retrieval? Okay. Plain language. Green equals plain language.
Green just means equal. Green is output. It's like what the model returns to you.
Code or plain language.
Lindsay asks you if you want to go embedded line. What's good? Fucking me, yeah. This is the best way to explain it.
Mm-hmm.
You get me? So it uses the prompt and the enriched information to then generate an actual output. So like it never uses any tokens on the RAG retrieval, since your prompt gets turned into a vertex and it kind of just returns to a thing. It uses your prompt plus the RAG to then generate a response. This is all one chat message. This is how it works.
Okay, so just give me 2 seconds here. So have you seen the architecture for the transport layer for model protocol?
Yes.
So hypothetically, the jousting thing I said, so we have clients set up as like, so you've got a client and the client has an inventory, and then the client can use that inventory to create a prompt or enrich a prompt which will then be transferred to the model to go through other configuration to then interact with, oh, there's a torch in the room, add torch to inventory, to then update the embeddings data.
You wouldn't. Okay, so yeah,
There's a
you
lot.
would use, like,
There's a lot more steps. There's a lot more steps.
I think you're honestly overcomplicating it. To be honest, it's just it's as simple as put the point in 3D space and then tell me what's the nearest thing, and then based on what's the nearest thing, I answer your question. I turn your point in your question into a point in 3D space. The points in 3D space that are nearest to that point are information that's related to it, and then using that information, I then go ahead and return an answer to you.
So the whole thing of it is I prompt the AI to tell me a story, tell me a bedtime story. The AI then has to I mean, there's a number of different configuration steps that are missed in that prompt, which then need to be either answered from the user, or where does the bedtime story repository lay and what's close to it, right? And then there then is the output, or there it then is the RAG retrieval, which then goes through the model again, which then is the output. Other than me overcomplicating it.
I'm just saying, like, the examples that you give don't really work for what RAG would be used for. It's more like RAG is like, it's like, let's just say that you're in like the fucking 1980s, right? There's no fucking computers, there's no Google. You basically, your teacher asks you to go ahead and write a paper on something simple, like you're gonna write a paper on World War II, right? When
Okay, let's
when you go to the library,
yeah.
you don't know which books you're gonna need, so you're gonna go ahead and ask a librarian, right? Hey, what books are related to this thing that I need to research? Then the librarian will then go navigate the library, find the books that you need, and then give them to you. And then you read those books, and then you go ahead and you respond to your professor, and that's basically how RAG works.
Don't get a man a book. Teach a man to be a librarian.
No,
But
not
the
always.
but the librarian gets you a book that teaches you how to be the librarian is really the. You don't think so? It's curation. It's curation and curating data. It's,
Yeah, but you don't
all I'm talking about is fucking a shitty, fucked up process of data cleaning. That's the only thing I'm ever freaking talking about.
Yeah, well, data cleaning, that's something else. That's something that I've been working on, which is cleaning context. This is a pretty good fucking presentation. They actually use this shit.
So with that note, as we hit our high of the end of the presentation, is there any other points that we've missed?
No, that's the most simple way to do it, right? Like, what I will say is never, no, 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 never, 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 ever, 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 embed code, because code has no meaning.
So code has no meaning.
Yeah.
So when the RAG pulls it, the model on the other side can't reinterpret that, or rather,
No, it can reinterpret it, but like, this is the reason why fucking open cursor fucking sucks dick, which is because of the fact that they embed code, they don't embed meaning behind it. It'd be a lot more expensive computationally for them to go ahead and embed code.
so very specifically though, since this is local implementation, don't don't I have the ability to then, let's say, so we have this curvature, right? So realistically, the way that I'm thinking about this is, and we've always had this same curvature, like over here to over here to over here to the. I don't know how to describe it right now. What was the last thing you were saying? Do you recall, or is it lost?
What, that fucking cursor sucks dick at embeddings because code
Oh,
has no
so
meaning?
the code has no meaning. So essentially, we take the code, we take the output, right? Whatever the output is,
Mm,
whether it hits the model or not. Let's drive it back to the RAG nearest points, right? The RAG return, the RAG retrieval
yeah.
before it hits the model. So we feed the RAG retrieval directly into an MCP server, which embeds the meaning. It says, yes, this is what this means. Passes it
I
through,
want to
so
say
it's
I
like
want to say yes.
it's
This is what it means. This is information that's the most related to your query. Because if, like, let's just say you ask a question that has nothing to do with the embeddings that you currently have access to, it would return absolute bullshit,
so
right?
if I provide a structured weighted data set in order to not necessarily
There,
affect the
there's
error,
no
yeah.
way. There's no structured way because you're basically how you, like the embeddings, how you turn your data into the embeddings. It's a black box. It's a black box of
Yeah.
information.
So, but if I hook hypothetically three, okay, if there's one black box that exists, there's one basic input output. If I change the prompt, how many times do I have to change the prompt after getting the same result in order to get one AI agent speaking to another AI agent, which will then be interpreted by the third AI agent with
No, 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 no.
three basic
Listen.
input outputs in order to generate a bedtime story.
No. You're confusing it. Confusing it. You wouldn't use embeddings for that. You would like embeddings are
This is
very
a
far
really,
away
really
from.
complicated bedtime story.
No. It would actually be super simple. Like let's just say you if you want to keep going down the let's go a little bit to the
Wherever you want.
let's go all the way over here to the right and
I'm with
let me
you.
create a new frame. I'm just copying it over, right? Um, and let me remove the inside. Okay, so go ahead and say example. So
Prompt. Can the prompt be bedtime story? And that's it. Not why does it
no,
bedtime story rag? Why is the rag attached to the bedtime story already?
here let me explain. Okay,
All right. Sorry for chattering.
all good. Please, please. Um, that story.
Like let's say I want to rewrite the Brothers Grimm. I want to continue his rights of work
Let,
or whatever.
let's just focus
Continue.
on
I'm
bedtime
just while you're explaining, I'm just chattering.
architecture, embedding, uh, embedding, uh, all bedtime stories, Doctor Who, to read.
Yeah. Okay, I understand.
So here you have the embedded data, and let's just say blue is equal to Doctor Who. Is it Doctor Who? What's the name of that fucking guy? It's not Doctor Who.
Yeah, it is
It's
Doctor Who.
no, Doctor Who is the fucking British TV show.
Yeah, well,
Uh,
that's. I'm thinking you're saying when you
um,
say Red Riding Hood, I'm thinking you mean classic story tale to Doctor Who, which encompasses basically all of time and space. Because it's the box is bigger on the inside, isn't it?
Dr. Seuss. That's
Doctor
the fucking name.
Seuss.
Yeah,
That's
we're just
funny. I thought you meant Doctor Who.
no. I meant Dr. Seuss or whatever. What his
I
name?
mean,
Dr.
Doctor Seuss
Seuss.
is good at telling the stories too. It wasn't bigger on the inside, but the Lorax knows a thing or two, I suppose.
Yeah, Dr. Seuss. It is. Dr. Seuss blue is equal to Dr. Seuss. Let's put this blue. Okay, and then let's go ahead and red is equal to, I don't know, what's another other famous?
Red Riding Hood.
Blue, bedtime stories, Red Riding Hood.
Yeah. A different flavor for certain.
Minus green is equal to, what's another bedtime story?
A story about sports.
Sports?
A history book.
No, no.
Fiction tales overall. The rest of the fiction tales. The overall rest of it.
Let's say horror. Let's say horror, right?
Okay.
Because sometimes they tell you like scary things. Horror, bedtime story, okay.
A scary story.
Scary story. Like, you know, like the original ones that used to read as kids and shit.
Yeah,
So
ghost stories.
A user. Please help me write a Dr. Seuss driving story that is scary, but has a deeper meaning about government district. I want to scare my kid so he knows not to step candy and shit like that.
Yeah.
Okay, so AI
responds with result prompt. Result ending.
No,
I mean,
not immediately. So we're gonna put this, and this is how we're gonna do it. Okay, so we're gonna put this on user up here, and then we're gonna go ahead and then put it. So this is the AI box. Okay. And here is where we're gonna go ahead and kind of just lay out everything. AI.
So I got one concern here, right?
Mm-hmm. No, there's no MCP at this
You're
point.
handing the initial prompt. Okay, hold on. How do I just move it around now? There you go. So it goes to the AI, and then from there, whatever the output in, whatever the result that gets brought out of the AI gets handed to an MCP server. So it's getting immediately handed off to another AI before it hits the end user.
No. There's no MCP server here.
In your example.
There's no RAG doesn't have to have a vector. RAG doesn't have to have a MCP. RAG has nothing.
I understand that, but I'm trying to make, because I mean your implementation of it in MCP is, I really don't see that anywhere else. You're the only one injecting data like that, to my understanding. You look at the workflow from these dev days. I'm sitting through 6 hours of these Microsoft developers, just looking at their workflow compared to mine. I mean, I don't know exactly what it is, but it just seems like everyone's workflow isn't succinct right now, because the work you're doing seems to be. I mean, go on. So prompt gets turned into a vector. The vector then gets thrown into the LLM. The LLM bounces back a response.
No.
Hits the model and gets turned into plain language.
The vector doesn't get thrown into the LLM. Okay. this is the LLM. Right now we are in the LLM. Okay.
Okay.
Let's just let's just do it like this. AI LLM. Okay, and let's separate this a little bit more easily. And then the vector, and then over here we're gonna have a different table. Okay, we're gonna have this table over here. We're gonna say embedding. Okay, and then the vector, and we're gonna go put this as another square, and then vector get on chart, and we return the inherit point. You do vector.
So this is the equivalent, right? This little thing.
Well, that's the
This is what it's. This is the RAG. This is where it's embedded all the data. This is what it's hitting, isn't
well,
it?
no. Those are the embeddings. RAG is the act of putting a point on those embeddings and then returning it.
So there's no basic input system for RAG as of yet. There's no Agent-MCP, but besides you, I mean, who else is doing this to this degree?
Yeah, there's a few, but they're like what's it called? I think Quad Taskmaster when it first came out, or like they're right now they're trying, but what they do is it just sucks. Like I'm not even joking. I've used their system. I'm always constantly comparing it against other people. And
What was can I look at it? What did you say his was?
Taskmaster, but it's not that good. They use
I got it. 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 Claude Taskmaster. I got it.
I personally don't like the implementation. It's just that repo owner, they've done a whole lot more shilling than I have for my project. I haven't shilled Agent-MCP in about like 2 months now, and like it just keeps getting stars, but people don't know how to use it yet. Like I haven't made an effort to like teach people, except like like people like you who come and like reach out. At this point, I'm trying to turn it into something a little bit larger, and I don't like really like sharing that part. But
You're fine. You're fine. You're fine. I get you. So this is the RAG process, but so if I may, let me just see if oh shit, I'm in the wrong spot. I'm in the wrong spot. Fuck me. Where? Hold up. Where? Okay. So this is effectively on the other side, right? And then I don't know how to get rid of the. I can add stuff, but get the text itself is. I'm trying to help.
so here, let me just copy in this over. Let's make a new chart, a new table over here on the right.
Yeah, but here, this is the main thing on this one, is, and I'll just continue to use the white. Is that this and what in the world is this? What font? How do I make my font different? Whatever.
But who cares about the font?
I just don't want it to look shitty, but go type.
Here, let me see.
There you go. I got it. So there's a black box, right? And this represents the okay.
No, the black box is this part. The black box would be here.
Okay, okay.
So here, let me just copy this one over. So this is what happens, right? This is over here the um, the put data into embeddings, and but this wouldn't be part of the. So data gets run through this black box, right? So this is the black box of embeddings. This is how it goes. This is how data gets vectorized, right? So data gets ran through a black box. That black box turns the data into a point in 3D space or in multiple dimensional space that represents the information. So whenever you go ahead and do a similarity search and you get that point, outside of getting that point, you get the information inside of that point.
Yes. Kind of.
So
Kind of like the tunnel of birds.
I don't really understand that example, but
Okay, that's. Well, I promise you, when the game, by the time the game's completed, the birds will show back up.
I don't even know what you mean by that. But if you want to show me what you've been working on, the cookie clicker stuff, I'd love to see it, honestly.
Well, it's the hold on, I can show you. Is there the essentially turned in, gets prompt, gets turned into vector, the black box, and then the data from all of the embeddings, right, is here, correct?
No. This point. Okay, so look. All right, go to this. Go to the one on the right. The chart on the right. I'm gonna just copy and paste this over here. So
The very first thing that happens is
So look, the first thing that needs to happen is this. First, you need to embed your data before you can even go ahead and successfully retrieve it, right?
yes.
Because, like, first you need to put your information in 3D space. After you put it in 3D space is when you can actually start using natural language to search for information. First, you need to embed information.
RAG embedding process.
No, so like RAG does not embed it. RAG
Okay,
returns
embedding process to RAG. Pardon me, other way around.
embedding generation for after embedding the information, you can use RAG to search and read it.
What was the representation of the square, like, all the way back initially, or is square just data? Square's just data. Okay, never mind. We haven't.
For what?
So in my head,
Oh,
it was the diamond specific was the
nothing has to do with shapes. I'm just doing that to basically differentiate.
but to correlate the thing that we were saying over here is that the embeddings, what was it called though, the agent that does the embeddings.
No,
Yeah, well,
the agent does not do that.
Well, there you have there is this black box here is this first part of embedding the information is you're
No,
handing
no.
it. You have to hand it off to the rag somehow.
Okay, so here, let me go ahead and make a new one over here.
This is like
Right?
fucking Inception.
Yes and no. There is an embedding. An embedding my basically um, typical LLM model, but with its
So you're not talking about an LLM. You're just talking about like a specific Python code.
no, I am talking about an LLM. When you embed stuff,
When I
when you
say
use an
specific,
embeddings
when I
model,
say specific LLM, when I say specific LLM snippet, it's too abstract. I understand why you're disagreeing.
but basically how embeddings worked is I did an amazing post on the subreddit about this. Here, let me find this. Here, I'll show you. If you want, look at my screen. And this is like a little subreddit post that I like not a subreddit post, but basically just
In,
like a,
in Swarm, I got you.
yes, like what is prompt engineering and why it matters. So, man, what the fuck? How the fuck do I get rid of this thing?
I think the part in which we're really struggling to connect here is our use cases for RAG.
Yes, 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 yes. Like I'm just trying to explain to you what RAG is because the use case that you've like basically like listed to me and how you intend to use it is like trying to use a fork to play a guitar,
To tune a piano.
right? Like you're trying to grab a car and use it as if it was an airplane, like that's that's what I'm trying to say. Like I don't know how
How
RAG.
many cars do you think I'm gonna have to crash? Um,
So for what? For to embed stuff for knowledge?
well, it's I mean, essentially, we're just talking about building out our prompt, right? I mean, very
Mhm.
specifically, and let me because you're referencing, you're making a very specific. Hold up, fuck me. Um, hold on, please, just a moment. And then I go here, 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 here. Which discussion was it?
Discussion and then it's why prompt engineering matters and why it works. I think that's one of my best like blog posts that I've written.
Okay,
And
essentially, the main point in which we're talking about here is our prompt enrichment, right? We're talking about the process of prompt enrichment.
well, that's how we use RAG in Agent-MCP. But I also use RAG. I turn images into RAG also, right? Like I like for one of my marketing projects, I paid a bunch of Indians and I also like manually did it where I grabbed the images and then I turned them into information and did like a quality score. So if I wanted to go ahead and retrieve an image that has a bunch of dogs in it, I can go ahead and retrieve images that have dogs and information and a bunch of stuff. So you can use RAG for a multiple like a bunch of information, but most of it is to basic for retrieval for retrieving specific information, right? So like let me
It's
look.
building. It's part of it is building the appropriate database, and part of it is prompting the retrieval for the rag properly. Is that fair?
Okay, here let me. I'm gonna draw. So These plus embeddings. Base model. Okay. So why would you use RAG? Okay. What is the purpose of So basically you have like a base model. Let's just say ChatGPT 4.1. Okay. Let's just use that as an example. Keep shit simple. So you have the base model, but with, let's just say you have a general AI model, you have access to information about your project or purpose without having to do the process of making RAG is essentially what the brain with memories already included. So we just base model. Yes.
So where? Hold on a second. I'm gonna do this really quick. Does this work? Oh, what was the album called? What was the album called for the Prism?
It's why it's in the discussions post.
The but the band though. For the life of
Pink Floyd.
Pink Floyd. Okay. Cool.
Okay. Let me know if you like read this one.
I'm really close to you. I'm really close to you. Just give me just a second. And then how did I just? Where is it? Here it is. The
Let me know.
Okay, I am nearly there. I am nearly there. I'm nearly there. I'm nearly there. So when do you want to? You tell me exactly. You start right now. You tell me when you're ready because I'm here. I'm ready. You got me my full attention.
Let me see this. Okay, so over here you grab the prism, right? The white light is equals the information. So the top one is how you embed it.
So I'm talking about this is the this is like this is all the way back. This is the finished product, right?
No, yeah. No, okay. So look, all right. So
This is very specifically. This is
no,
the set
like
of this
I
this
get it,
is
I get
this
it,
is the
I get it.
MCD. This is the MCD.
The okay. Let's take this a little bit better on the MCP case. So let's just say
I'm too much abstraction. This is the monolithic text that I've spent years upon my life. Okay, just to accumulate these knowledge of tools together. But continue. Go where you go. Where you're going.
so look here. We're gonna say white light is equal to MCD or data. Okay.
Okay.
We're just gonna use this. And yeah. If this photo is not transparent.
Just go over top of it. Are you trying? It's just keep going. Do your thing. Problem solving something I don't need the problem solved.
No, yeah, 100%. I just want to get like good high quality images for this.
And realistically, this in that I'm talking about, this orange in at the front of all this, the initial prompt with the user, it doesn't really matter what it is. We're gonna throw them into an environment in the first place anyway, and then they just have to make a decision. Doesn't matter what the decision is. It could be between like in the next 30 seconds, wiggle your either your finger or your toe, make a decision. By the time you've made that decision, you will have already have moved it.
Man, dude, what these guys are fucking scam. Fuck is this shit? Open tab. Please don't tell me that this shit is. Of course it's
What are you trying to get? I don't understand the here's the
I'm
bread.
I'm trying to get the assets. Oh man, dude, what the fuck is this? Does nobody
Send
get
me that
no?
transparent light really quick. I'll just do it.
Just like search it up yourself.
Okay.
This is ridiculous. Nobody wants to do fucking put out a white light and transparent background.
Close. Then this, and then I do this. I wanna wait. Fuck me. Add alpha to challenge. Delete this. Exit. Save as. Wait, no. Exit. Export as untitled.gif in desktop. Export. Oh wait. Ah shit. I don't even need to export. I'm fucking. I should just be able to copy it and then come over here. There you go.
Oh, this one's it. This
I
one's
got it. It's on here. I got it. Is that what you're looking
Oh
for?
no,
What color?
no,
What color? What
this.
color do you want it? What color do you want it?
No, here. I already got it. I already got it at the bottom. Look, this is what I want.
Okay. I'll just
Okay.
check this. That was fun for a second, though.
You're getting, dude. You must, you have a good amount of experience.
Well, I mean, if I gotta throw
yeah.
in GIMP, if I really like, if I gotta solve a problem, if I gotta do my production work, like, it's just a matter of problem solving. That's all it is. It's how many problem solving days can we have? How many problems can we solve? That's the name of the game, isn't it?
100%. Agreed. Yeah, I just need like quick rainbow light. Rainbow light green. And rules, color transparent. Sure. Man, I love Google.
Mm-hmm.
Oh man, PNG tree. Oh hell no, they put some fucking proof in next. Fuck wow. Oh man, that one's not even transparent. Let's try.
What? You need like you need? I don't understand what you need yet.
No, that looks retarded. I'm just trying to get like a good transparent like color PNG.
Rainbow, just like a full
Here we go.
rainbow.
Got it.
Okay.
Yes. Okay. Oh my god, this is perfect. We're gonna go back to the.
Oh yeah. I'm with you. I'm watching. Yeah. You do your thing.
And we're gonna go is visually understanding. One equals in that information. It is going to be it as so sorry. Information understand represent information you can understand is clear.
Why don't you can you copy the text as well? Or we
Which
just
one? Okay.
I mean keep going, keep going. The white light equals
From where?
the down here. This one. Like just this white, there you go. Just to keep that with it, to keep the idea. Do you know what I mean?
Mhm. Okay. Let's put this. Oh, well, let's put this off. All right. We'll put it there. Right. We're gonna not do MCD. We're just gonna call this a state. Just so this is not like Agent-MCP, so you understand everything. We need to separate and understand this data with running it through this model. In this case, it just showing the right situation. There's the data in billions of specific colors. Colors are very rules or connections compared on the so for example, in color might be hello.
Huh? Oh.
Color quickly something.
Ooh. What was that? Oh, it was you. Okay. Where is it? You good? The where the freak? I'm in the wrong spot.
So you have to listen to my shitty ass microphone.
You're good. You're good. You're good. You're good. We'll work it out.
Just keep. Oh my god, dude, what the fuck's going on? Okay. And then embedding model. I'm gonna make this a little bit smaller, just this image, just so I can fit more page onto this. Happy. Let's put into the embeddings model. Let's just draw a thick white line. Oh wait, okay, I can draw a thick white line with this. Can I rotate this? Yes, I can. I love this program. Like, let me know if you're understanding.
So what is embedding model? So the embedding model is what is essentially what we discussed to be the the diamond concept, didn't we? You're gonna have so much better time if you type, because there's not a chance if you don't type. There's not a chance. Embeddings model is basically hard coded to always represent the same information, but it can pull all of that information and provide backup information for it. Quote unquote colors. Here, let me help you out a little bit here. Oh, and I could move you too. That's interesting. Do you even notice me moving you? But it stays linked. That's so strange.
Yeah, it's all good.
So, okay, yeah, let me. Embeddings model is basically hard coded. So you get the same information out. We use the prism function to basically reverse the process. And then instead of turning the information, storing it as clear, we run our prompt and we store it as black and white. And then we go from a black and white, and it's just the model at the front and the end to really do a lot of. Well, I mean, colors. I mean, it's. So your colors to me is the same thing as this. So let's. So this is fucking upright first off, and then. So it's the. If you look down and to the right a little bit, it's the you've got embeddings on either side, and it's still going through the black box. There, because the rainbows are just sets of instructions.
No.
What I'm telling you is that I'm trying to use the embeddings as sets of instructions to pass through to other clients behind it.
Yes, so you would allow for that.
I think you said yes. I lost everything else. What would I use then?
Mm,
Because as far as I'm concerned, the thing that I need to be looking at is how to implement Haystack. And it's to implement Haystack as the RAG agent. As for what would do the which models would be GitHub as well. There you go. So I just need to figure out how to properly implement Haystack and then use it to call tools for the MC. I need it to be a server, and I'm going to use VS Code as the client. It's going to provide tools to the client. So think of it like this: like we. Oh yeah, I understand that. I'm sure about that. I'm trying to fucking tie water together here, dude. Like I'm literally just like I wish I could just take a glass, but I'm literally trying to just get water from thin air. It's literally I understand that I'm using several of them together. Not for your use case. I want to be able to take I want to be able to call from an MCP client two different MCP servers, have two different sets of instructions and resources, and have those two different MCP servers interacting. So the MCP client, we're in cursor for fuck what it's worth. Server A, and server B. So the RAG, hold on, just a moment. So the basic input output. So let me do this. So this arrow is going to represent let's just attach it, fuck it. This is going to represent the MCP server. This is going to hold on. I need to make sure. So there's this basic interaction with this one, okay? This MCP server is then connected to. Can you put a C in there, please? And then this talks to this, and ultimately the thing, to answer your question very specifically to the best of my ability, hold on please. I'm coming. I'm Russian. I'm coming. Hold on. I'm not Russian, but hold on a second. And this is the RAG system. The RAG system's over here. These MCP servers are the RAG system. And as for autonomous, I don't know, you live, breathe, work, sleep, eat shit yourself, don't you? Let me make a little bit hold on, just a moment. So I need to go here, I need to go here, I need to go here, I'm gonna go here, here, and then did I fucking delete it? I fucking deleted that motherfucker. Me, referring to myself. So where's Git? Fuck me. Am I just fucking high? I swear to God, I know that's okay. Let's think before I get mad. Let's just react rationally before I get angry and frustrated. Get rid of this. I don't need this. Just start throwing shit away. Just throw everything away. If I just throw everything away, it'll be really easy to find it, right? here.
Let's see.
Oh, wait, here, I got it. Check this out. Just read these docs. Just check these docs. I'm going to just DM them to you in a second. As soon as I get there. Check out the
No, I've seen all this. I've seen this. But you need to understand MCP better. Like you need to go and see what, because Cloud Code doesn't offer the prompt solution publicly. They'll do that through with a slash add.
the um so where does that leave us at this point? What have you drawn up? What do you got? Where are you working?
I'm only translating something, like, give me 1 sec.
Okay.
1 second. Okay.
No, I got nothing. Okay, I'm with you. I'm up here. You're going down? I don't know where you're going. Right next to you.
Phone, turn on. Phone turn on, dude.
Is it plugged in? Nah, I got nothing.
CP server see, like these are things that discussing inside of like the original MCP development team where you use an MCP server to communicate with other MCP servers. Okay. So unless MCP server A is an agent, MCP servers to agents. Everyone's back. You hear me better now?
Oh, thank God.
Okay, all right. So look, what I was going to explain is, all right, like you have a fundamental misunderstanding about like how to use MCP, right? So unless MCP server A is an agent, you wouldn't have another MCP server call other MCP servers unless it's an agent. MCP is only for agents.
So this is both a server and a client. In their architecture, this application, this is not a let's call it Dungeon Master server or DM server.
Okay.
Does that make sense to you?
No, yeah. It makes sense. Yes.
So in this one instance, we're just generating one room with a torch in it and nothing else. And it's to hold the state, to be able to be like there's a state with the torch in your hand and a state without the torch in your hand, both representing close vectors on the XYZ charts, which is in the same chart. So it's how do I layer the data in properly in order to get the desired result of which I'm putting together, which is basically like if you coming back to Pink Floyd, you go from the white light, you go from the prompt, which is what I'm providing to you, and the colors is like the key for reading the inventory, the dungeon state, the environment. It offers all the resources. It gives you the selection of tools for you so that you can either look around, you can do a flip. The tool.
You wouldn't use RAG. You wouldn't use RAG for information. You would just have a status monitor for what's currently happening. You'd use RAG to look in the past, like key events, key things that have happened. So let's just say that you're playing. Let's just say that this is like a Dungeons and Dragons campaign, right? You're talking about retrieving actual information about the current environment. You wouldn't use RAG for that. You would use RAG for, okay, what happened in dungeon 3 days ago? Something that, let's just say, it's outside of the context window of your AI, or it doesn't know it because it forgot, right? Like, you'd use RAG for those situations. If it's something like, this is the current environment that I'm in, right? I'm inside of this room. There's a door to the left. There's a table on the right. What do I do? Like one of those old dungeon crawler games. You wouldn't use RAG for that. You would just use kind of like a status monitor that, like literally like an API. That would be an API. RAG would be something like, oh, do you remember this conversation that you had with this bard? Something like that. Like that's what
That
RAG would be used
very
for.
specific context is the embeddings that we'd be pulling from. That would be what Dungeon Master, because Dungeon Master is going to have an infinitesimal database. It's literally going to just contain the course of human history at a certain point.
Yes, but then what happens is once you have too many embeddings, that's when things start getting south. Like more embeddings does not equal better. Okay, so you can't currently
It just requires a different. You just have to break down the subset of instructions even further, and it makes the abstraction and decoding the abstraction even more difficult.
It has nothing to do with the with instructions. It has to do more with the capabilities of the black model of the black box.
So, in combination with where exactly I'm going to need the black box in doing the Dungeon Master calculation, I don't know. Personally, I don't care how I tell it to do the math. Like, as for the specific instruction sets on how to interact with the environment, all I can tell you is that you're in the environment already. That sounds really silly, but what's all
It's
this
not.
mean? The auto compact issue? Nice.
No, like I have this guy from Spain working on agents. So, like, let me show you how this works. Like Agent-MCP. Okay. So look. ./c. Boom. Like I do this with I have a bunch of agents always running 24/7 basically. But we'll just go down to the Clover one, which that's the one I'm in. Okay. So here, I want you to we are going to test the RAG retrieval. Okay, and you know what? Let's go ahead and even go a step further, and let me show you the debug logs, so we can go ahead and do this a little bit even more fun. So here, we're going to pin this. We're going to keep this on the right. Okay. Let's keep this up here on the right. You like my Swarm terminal? It's fucking amazing for fucking vibe coding.
Yeah, I see you like doing everything in command line. I've been using VS Code the entire time. I'm entirely implemented through VS Code.
Well, we're working on an IDE right now also, so I'm mostly working on the terminal, and Clarity is working on the cursor VS Code version, which is going to be a little bit better because it's all written in Node, where you can just launch MCP servers automatically. So currently, how I prefer working the terminal because I'm always working from my phone and on the go. I have to SSH
That's
into
okay.
computers
Yeah,
all the
yeah.
time. So here, like over here, I can go ahead and just launch agents from this side. I can
So
also
are you launching a RAG agent?
I'm launching an IDE using Agent-MCP as the coordination and context framework. And I also created my own version of Context 7, but outside of documentation, we're also indexing news and like financial information like SEC and shit. But
You're just churning data
it's a
then.
yeah. We're aggregating data and making it very easy for AI to look at to like receive it very easily. So currently, right now, we have an MCP manager where over here I can just launch MCPs automatically from the terminal, attaches into Cloud Code. I can add, what type of MCP I want, how to run it, what template I want. This is mostly for me, but
So this is your server manager that's going to be working towards your IDE.
this is more like the terminal one. Like Clarity's
That's
working
fine.
on the
That's fine.
IDE.
That's just fine. If it's it's the same language. I mean, we're not. I'm just wondering. The function is to manage the multiple MCP servers.
Yeah, launch them, run them, manage your agents, manage the context, and like basically in .agent, we also are making it so like let's just say that I worked on a project and we only have the code. I wanna make it so anybody can download a GitHub repo and they basically have a built-in Dev with all of the embeddings and memory already inside the code base. So let's just say you import the Agent-MCP repo. There's like already context and embeddings inside of that repo that you can ask to basically help you modify and understand the project a little bit better. So making like context entries and embeddings a little bit more universal between projects.
I understand.
But here, let me show you the actual RAG functionality. So you see how we have the RAG index cycle up here. So here, let me just reset this, and let me go ahead and run inside the Claude, right? And then here we're gonna do this. You are the admin agent. We gave it the admin token. Okay, we are going to test the RAG implementation. Please make it so okay, RAG implementation inside of Agent-MCP. We are going to embed a long piece of fake context. For example, let's do a fake API and its documentation and how to call it and stuff in a way where return useful knowledge about it. In this case, let's make a big API context about API that returns information on doc3 and stuff. After we create the context entry, let's launch an agent to basically document this existing context entry and to make a markdown file with all of the information that we on one. Tell the agent that the API isn't online, but we are just trying to document RAG slash context agent. Okay, so let's do. So this is what it's gonna do, right? Admin agent already has its token. We already gave it over here, and let's go down. It's going to help you do the RAG thing, and then it's going to call the tool right now. And we're going to see up here how it uses it and how it works.
Yes. So you have markdown files in there.
Well, it automatically indexes the markdown files and also embeds them inside of context. We do we create a hash for the code base, for all the code base, and then if that hash changes, we see which files hash is different, and then that's how, we re-embed things.
Gotcha.
A very easy way to find changes if we just like hash everything and everything has its own unique hash. If hash does not equal previous value, it means file was modified. So here, it went ahead and started and did it. Project context was added. Oh, let's make this a little bigger. Now let's see what's going on. Well, I guess it's not updating inside of the tmux, but it's up. We'll make this a little bit smaller.
But I think I really believe you've definitely built a RAG from scratch, essentially.
No, it's not from scratch at all. I just used previous implementation. Okay, so now let's monitor this agent. Okay, so let's go ahead and create a new tmux. Let's do products list. Oop. Oh. See. Okay, look. Okay, RAG documentation specialist. So let's see. I didn't send the message. It just took a little bit. Let's see. Let's see what happens. Okay, so it starts seeing the task. It gets the task. Document dog breeds API from RAG context, right? Perfect. I can see I have one task assigned to me, and it hasn't used the RAG yet. And let's see. It updated the task status to in progress. Okay, it's still working. Let's see what it's doing. Okay, so then it's going to go ahead and go through the proposal chain. Now this is when we're going to see the RAG. So basically, I am inside of my universal prompt. I make it ask 5 to 7 questions with the project RAG to understand the project. So
at this point, we've gone from prompt, we've hit the model has done some work, and at this point, we're in the embeddings. We're in that diamond.
No, so look here. I'm gonna open up Excalidraw again, just so I can draw this out. So this, let's just say that this is Claude, right? Here, Claude sends a tool request to Agent-MCP. Okay, so Agent-MCP has its own dedicated RAG agent. Right, so RAG agent. And so basically it sends a prompt, RAG agent, gets the prompt, plus then, gets the embeddings, like the input embeddings, and then plus prompt. And then after that, it sends back a response. But this is like an agent within Agent-MCP.
Yeah.
This is basically how it works. But let's go back to the start. Let's see. All right, so this. Okay, so look. Oh my God, this is so fucking good. This is so cool. Look at this shit. Oh, look how immediate that shit was. Okay, so look, document task requirements. All right, yada yada yada. It asks it. Okay. Based on the provided context, there are indeed additional SDKs and code example beyond JavaScript and curl that should be documented for the dog breeds API. For the retrieve context, C chunk 3, there is a Python SDK available along with installation and usage examples. So pip install dog breeds API, it's all fake information. JavaScript and SDK and code examples already mentioned in your query, but for completeness, tells you how to install it. What are the code examples? What are the curl command lines, right? And then it tells you how to implement. And so this is kind of how it goes. This is everything that we injected from the admin agent. So if we go back to the admin agent and we see what the guy actually fucking embedded, right? Look at this shit. He embedded dog breeds API, complete API documentation for the dog breeds information API, includes endpoints, authentication, response formats, and authentication, tells you the API key, tells you everything about it. And almost immediately, my RAG system already embedded it and worked for retrieval. So it gives you everything. It's like, okay, now extract the actual context and create the comprehensive markdown details. So dog breeds API, comprehensive documentation, description, complete API documentation, endpoints, all of this, and I truncate it just for tokens.
Okay.
But yeah, like outside of this is why my system, I'm not gonna try to get like too confident. I hate having like an ego about these things, but I have a better like context implementation than Context 7. I have a better like agent coordination system.
Tell me if I'm wrong here. Context 7 only pulls like documentation. As far, I mean, that's the only thing I've found anything for it to do.
Mm-hmm. Okay. It does documentation, but
it doesn't seem. It doesn't. Like, I don't understand.
Right now,
there's no instructions.
It's getting like a little better. Yeah, Context 7 is just for context about what software you're using. Agent-MCP is context about your project and how to coordinate the agents. It's like Agent-MCP is an amalgamation of everything that AI and the tools like needs. So Context 7 solves one issue, which is context for the documentations that you're using.
Right.
Like Taskmaster basically does only tasks for agents. Then there is this other shitty ass project called like I think like Claude Team or some bullshit like that, which launches a bunch of fucking agents. Also fucking sucks dick. So like this is I think like compared to the fucking market, like this is probably like the most whole like MCP that like encompasses everything that like AI basically needs at this point. So yeah, now it's done, right? So here, let's go back. All right, agent is done. Let's see what the guy did, and let's judge the RAG retrieval. You can also just directly look and read the pane, judge quality of the responses. So this is why like my fucking RAG system is like fucking effective, and this is not only good for code because like I don't put into RAG context that is like hard coded. I put into RAG context that already has meaning, making it a lot easier for it to search. Right? The fact that I go ahead and I don't embed code, right? Because this is what happens with code. We can go ahead and even visualize it in you know, cursor embedding approach. Let's go ahead, see code. Right, let's just do this. Code. And I'm literally gonna fucking visualize it for you. This is about the coolest part. Code. Embedding this model. And let's just go ahead, copy this again. Let's just go. And let me just copy over this fucking thing from over here. Okay, so let's just say that their embeddings data ends up looking like this.
Mm-hmm.
when you embed with fucking code, it's so shit. Dude, it's so fucking shit. All right, let's see this. Okay. And copy this. Put this over here. Agent MCP embedding approach. Context. Sorry.
Yeah, I gotta run to the bathroom really quick. Hold on a second.
All good, all good, all good. Do your shit, my man.
Okay. Oof. Context first, code second.
So what are the cons of this approach, right? Of Cursor's approach?
It's hard to retrieve. It's hard to get the right thing back.
Yeah.
They can do the they can
Because,
if they
like,
can
look at
implement
it.
it into
Look
the
what
RAG,
happens.
but getting it back out is the problem.
No, it's not about getting it back out, right? It's about separation, right? You don't want context to be mixed. So you see how when you embed code, because code is very, code is similar. There's no such code always
There's
has
no
to
break.
follow the same guideline. There's no breaks. So like, let's just say that your OAuth file will look very similar to every other fucking backend functionality. They really look almost exactly the same. It just uses, code, right? But when you go ahead and start embedding meaning related to that code, right? You take an extra processing step where you go ahead and grab that code and you embed it by its meaning, not by what's in the code. It's very easy to retrieve and search. Which one do you think it'll be a lot easier, right? Because let's just say that we create a point, right? That's right here, We create a point that's like right here. You're looking at my screen, or are you looking
I
at
got
the?
you. I got you.
Okay. So let's look at my screen.
I can't
right?
see your
So
mouse.
if we retrieve right here.
Go on.
Okay. Like you see this white circle, right?
Yes. Here, I can see your mouse now.
You see, because there's so many points that are densely, populated.
Yeah.
We are over here getting context from things that are separate, right? Now we're over here fucking pulling from the green. Now we're over here pulling from the red. Everything's kind of mixed up and jumbled together. This is awful embeddings. If you want clear embeddings and if you want to get pull information correctly, you need shit to be fucking separated. Because if you ask about something specific with the Agent-MCP approach, things are so different by their context and not by their code that it's very easy to retrieve, right? It's clean, it's not congested. So this is why fucking Cursor sucks, right? Because they embed things with the fucking, by the code. Oh yeah, we're gonna go ahead and embed the code to tell the AI where it is. No, motherfucker, no. You're what the fuck? When you talk to AI, you're not saying, look at line 32 in this. Dude, you're just gonna say, hey, in the OAuth, we get this error over here, and we need to fucking improve it, right? So you go by meaning, by context, not by hard deterministic code. So you want to make sure that when you embed data, one, that it's separated and you actually differentiate it correctly, and then two, that it's it's easy to retrieve. RAG is one of the most complex things about
I'm gonna need it. I'm gonna need it. I'm gonna need it. I know I'm gonna need
I don't know if
it.
the cookie clicker, my man. I'm being honestly like you're gonna need it for developing cookie clicker, but at the same time, like I'm gonna tell you, Yogi, you're gonna spend maybe the next 2 months working on a fucking RAG implementation. I would honestly go ahead and dude, like you have my full permission. I know that you're recording. You have my full permission to grab Agent-MCP, refactor the RAG part, and then like put that in because the RAG and Agent-MCP is reliable. It differentiates things, right? And it's used correctly. You can go
Well,
ahead and
yeah,
strip away
it brings
all
down.
of the
It works
offensive
from MD
matter.
files. It's clean. It gets the job done for. So it stores everything and you can pull from it, right?
Yes, and it does it in a way where it's reliable and cheap.
Can you show me? So I mean, it's pretty simple. Hold on. Let me get to your repo first off before anything else. Okay, I'm at your repo. I go to uh, um, Agent NPC right here, or MCP, and then where's the RAG?
RAG is in features. Go to the features folder. Features, RAG.
Features, RAG, and then do I need the dashboard?
No, dude. I don't even use that dashboard. That dashboard is for human beings. That's it. It's for human beings, not for. I don't use the dashboard ever. I know what's going on with my projects. Like I made the dashboard for people, like not for me. I know how
Yeah,
my tools
yeah,
work. I don't
no,
need to.
no, yeah. You're all command. You don't need a GUI. What the fuck am I saying? So, but that RAG folder,
No, I
you're
love
telling
GUI.
me?
I love GUI. Like it's just like I don't think you need to like manage like for example here. Let's go ahead and open up a new pane. So W Control P N Control P W. Oh wait, no wait. I want to make this one floating toggle me. Okay, there we go. Now we get better. Here, let's move this one down. This one smaller. This is the Agent-MCP one. This is why I like Zellige. Zellige is a way more comfortable space than VS Code at least for me. So let's go to Agent-MCP and let's go see the Agent-MCP / dashboard npm dev. Let's go. Let's check this shit out. All right, and let's connect to the agent development. This is what the project currently looks like.
Yeah. So this is, but this is through the this is the dashboard, isn't it?
Yes, this is the dashboard. This is how task organization works.
Okay.
These are
So
the tasks, and these are the tasks as the phases go through.
so let me ask you this: is this organizing the are you telling it what's linked up, or is it making its own decision upon that?
I don't tell it what's linked up.
Is it the file structure that's determining that, or where is that coming from exactly? How does it make the determination for this one to connect to all of the other ones?
Well, this is like Git. Okay, like Git tree visualization.
Okay. So it's just tree.
It's not trickery.
No, tree.
Yeah, it's like a task tree.
Okay.
So like so there needs to be a lot more work done on the UI.
I'm not
this
even.
guy has been working on it.
I'm not even worried about it. Like that's. I'm gonna try it. I'm definitely gonna try it.
I personally don't do anything through the fucking dashboard. I'm gonna tell you right now, this is not something I recommend. You gotta do this shit yourself. But basically, this is how it goes, right? So you see how this is the master task for everything?
Yeah.
So implement full screen quote. This is like a little bit more into the project. But in order to finish this task, which is the phase one, it went ahead and like, you know, oh, for me to do this task, I need to do these 3 things first. And then it starts going down the first 3 things. And then, oh, for me to finish the first of the 3 things, I need to do these other subtasks. And then to finish one of those subtasks, I need to do this other subtask. So you see it kind of starts splitting up into kind of like a tree, depending on what needs to be done.
Yeah.
So it's kind of like this. So let's just say that this is your phase 1. Phase 1 needs to finish these 5 tasks. So in order for me to do the server, first I need to do the routes, then I need to do the model, then I need to do the bin, the app.js. Then after that, like for phase 1 to be finished, I need to work on the client. And so for the client, I need to work on the views. And then I need to work on the fucking JavaScript. And then the JavaScript, you know, goes into the directive controllers. And the controllers, I need to go ahead and do the sign-up.js, postmate.js, right? Everything starts being broken down into its most essential components, right? Because this all goes back down to what the logic behind Agent-MCP is. Agent-MCP is basically here to, we take a project, right? Like, so we grab a project and we want to go from idea to reality, okay? We want to go from idea to reality, okay? So project to, let's just go to final product. And this is not a one-step thing. You can't go from project to final product, right? Like everything in life is a matter of linear events. Everything has a cause and effect relationship, and things go like this. Like you need to go ahead and then break it down into its most essential tasks. We break down everything that goes on into its smallest components, right? Like for me to go from point A to point B, if that's like the trip, I need to go through point A, point 1, 8.2, 8.3, 8.4, 8.5 before I go to B. I hope you understand what I mean by that.
You got to hit every bird along the way. Yep.
Like for you to run a mile, you need to fucking step every single step in the mile. You can't just teleport. Exactly. So what we do with Agent-MCP, because what are hallucinations? Hallucinations are assumptions. That is it. A hallucination is equal to an assumption from the AI since it hasn't been given the context. So when you have AIs hallucinating, right, it's because it doesn't have enough information and it needs to make it up to go ahead, it needs to assume, right? Or it needs to make it up to go ahead and finish the task. It's very lazy, but that's how hallucinations work. You don't hallucinate if you don't know, right? It's like, that's how it goes. So basically, like, I hope you kind of like start seeing like the bigger picture, where if you want a team of agents working together, you not only have to control how you break down the tasks and how they work on it, they also need to be given context and information that makes them never assume. And by never making them assume, you go ahead and make sure that their output is deterministic and that it works.
At that point, I'm gonna say, I'm gonna say this. We're cutting this in 5 minutes for certain because I'm not making this that longer than 3 hours.
All good.
If anything, like, comment, subscribe. I love you guys. I'll see you guys later.